Hi, welcome to class. Today we're going to be talking about compound inequalities. To start with, here are some real-world examples of compound inequalities. The food should be kept between 32 and 40 degrees Fahrenheit. We can write that like this, with X standing for the temperature of the food between 32 and 40. Or we can separate it and say that the temperature of the food has to be above 32 and it also has to be below 40. The children at this camp are at least 9 and no more than 13 years old. One way to write that is to say their age is at least 9, greater than or equal to 9, and the age has to be less than or equal to 13, no more than 13. We can also combine those like this. Put the age in the middle between the 9 and the 13 so that it's greater than or equal to 9 and less than or equal to 13. You get a B if your score is 80 or more but less than 90. So one way to write that is to say the score is greater than or equal to 80 and less than 90. Or we can put it together like this with the score between the 80 and the 90. The picnic will be moved indoors if the temperature is under 60 or over 90 degrees. So that means that what would make the picnic get moved indoors is if the temperature is less than 60 or if the temperature is greater than 90. And we can't combine these when they're separated with the word or. So when you've got the word and, that means that both parts have to be true. What we want is the intersection or the overlap. If there's the word or between two things, it means that one part or the other, or both, must be true. So we want the union or the combination. So suppose x is 2. Is it true that x is less than 4 and x is greater than 7? Well, if the x stands for the number 2, that is less than 4, but it's not greater than 7. And it has to be both to count for the and. So the answer to that first question is no. Is it true that x is less than 4 or x is greater than 7? Well, let's see. 2 is less than 4. And even though it's not greater than 7, it only has to fulfill one or the other of those conditions. So the answer to the or question is yes. 2 is less than 4 or greater than 7. Suppose we had to graph x is greater than -3 and x is less than or equal to 4. Here in green, I've shown all the numbers that are greater than -3. And then here I've added in purple the numbers that are less than or equal to 4. Now we have to be both greater than -3 and less than or equal to 4. So we want just what those have in common, just where they overlap. So the bottom part in red here would be the solution. How about this? X is greater than 5 and x is less than or equal to 1. In green, I've got the numbers that are greater than 5. In purple, here, I've got the numbers that are less than or equal to 1. And what do those two sets of numbers have in common? Where do they overlap? Well, they don't have anything in common. So the overall solution is just the empty set. It has no numbers because there aren't any numbers that are both greater than 5 and less than or equal to 1 at the same time. Now, what if we had the word or there? X is greater than 5 or x is less than or equal to 1. Now we combine those two. We take the union. We take anything that's in one or the other of those, and so we get these two separate parts of the number line taken together make up the solution set. When we put things together like this, 3 is less than x is less than 8. that means that 3 is less than x, and at the same time, x is less than 8. So if you look at it from x's point of view, the x, the number that x stands for, has to be greater than 3, and it has to be less than 8. So it has to be between the 3 and the 8. So the numbers that x can be are all these numbers here that are between 3 and 8. We could also look at it from the other direction and say that 8 is greater than x is greater than 3. So here I've got them arranged from smallest to largest, 3 to 8 with x in the middle, but I could arrange them from largest to smallest, 8 down to 3 with x in the middle. But what I can't do is something like this, 3 is greater than x is greater than 8. This doesn't make sense because it's saying that x has to be on the small side of 3 and on the big side of 8. And there aren't any numbers that are both less than 3 and greater than 8. You've got 3 on the big end and 8 on the small end, but that doesn't make sense. You also can't run things together where the inequality signs are pointing in two different directions, like 3 is less than x is greater than 8, or 3 is greater than x is less than 8. That doesn't make sense. Now we're going to solve some compound inequalities. The directions say solve each compound inequality, write the solution set in interval notation, and graph it. So first we'll solve, and then we'll do those other things. So here we've got two separate parts with the word or between them. We got to work on each part separately to get x by itself on one side of that inequality. So for the x plus 3 is less than 5, I can subtract 3 on both sides, and I get x is less than 2. For the x minus 1 is greater than 8, I can add 1 to both sides, and I get x is greater than 9. So I end up with x is less than 2, or x is greater than 9. Here's what that looks like on the number line. And then in interval notation, these are two separate pieces. This is the interval from negative infinity to 2. And this is the interval from 9 to positive infinity. And since we want everything that's in one or the other of those taken all together, here's how we write it. The interval from negative infinity to 2 union the interval from 9 to infinity. Next example, 3x is less than 4, or 3x minus 4 is less than or equal to 5, and 5x is greater than or equal to 30. Again, work on each separately to get x by itself on one side. With this, if we add 4 to both sides, we get 3x is less than or equal to 9. Then divide both sides by 3, and we get x is less than or equal to 3. With the 5x greater than or equal to 30, divide both sides by 5, we get x is greater than or equal to 6. So it says x is less than or equal to 3, and x is greater than or equal to 6. But that's a problem. You can't be both of those things at the same time, so there really is no solution. There is no number that satisfies that whole thing. And here we have a sort of a three-sided inequality. Negative 1 is less than or equal to 3 minus 2x is less than 11. What we want to get is just x by itself in the middle between the two inequality signs, and then numbers on the outside so that we can find out where x has to be. And whatever we do, we have to do the same thing to all three sides. So right now I've got a constant term and an x term. Let me leave the x term here, but get rid of the 3 by subtracting 3 from all three sides or parts of this compound inequality. So if I subtract 3 from all three sides, I get negative 4 is less than or equal to negative 2x is less than 8. Now I need to go from negative 2x to just x in the middle, so I divide by negative 2 on all three sides. But since I'm dividing by a negative number, what do I have to do? I have to reverse the inequality signs, flip them around so that they're pointing the other way. So dividing through by negative 2 gives me a negative 4 divided by negative 2 is positive 2. Negative 2x divided by negative 2 is x. 8 divided by negative 2 is negative 4. And I flip the sign so it's 2 is greater than or equal to x is greater than negative 4. So x is on the small side of 2, or it could be equal to 2, and it's on the big side of negative 4. So it's between 2 and negative 4. Could be equal to 2, can't be equal to negative 4. It has to be strictly greater than that. So here's the numbers that x can be, and this would be the interval from negative 4 to 2 with a round parenthesis by the negative 4 and a square bracket by the 2.